In this video, we will show you how to use the Smart Pointer to automatically delete the dynamic allocated memory in C++. So we know in C++, when you're using the new keyword to create dynamic allocated memory, you need to use the delete to release the dynamic memory. But in Java or C++, we all do that automatically. We call that garbage cleaning. So that's why from C++ 11 and above, we introduced the Smart Pointer to dynamically allocate memory. And then you don't need to worry about to delete the memory after you finish the program. So using the Smart Pointer, the first thing they will dynamically allocate memory. Then they will delete for you. So there are three types of the Smart Pointers. So you can have the unique PTR, shared PTR, and weak PTR. So they are according to the ownership. But in this class, we only talk about the unique PTR. So this unique PTR, they only allocate one dynamic memory allocation. So then we're using that to do any assignment or process. So when you try to using the Smart Pointer, you have a memory header file you need to include. So that is the memory. Using the angle bracket, that means they are default. It's a default library from C++. So here, when we want to create, using the Smart Pointer to create dynamic memory allocation, so of course, you still need to assign the data type. So what we do is the unique underscore PTR followed by the angle bracket. So this angle bracket, you will specify the data type you want to create. Then followed by the pointer name. So the pointer name, you have a parenthesis. So that's here you will create the dynamic memory allocation. So we're using the new keyword. So this data type will be the same as in the angle bracket. So after we write like this, what they do is, you see here when you have the unique PTR, angle bracket contain your data type. So that's the data type the pointer will point to. So the PTR is name of the pointer. So then in the parentheses is expression that dynamically allocates the memory. So that's earlier we talked about. In the angle bracket, we specify the data type. So when you knew the data type, don't forget they need to match what we have in the angle bracket. So then those new memory allocated, dynamic allocated memory will be refilled by the PTR. So we see how they work in the program. So we see in example 10, you see here we include the memory library. So we're using the IOString to display the output. So that's just define a pointer variable called PTR. We refer this PTR to an int variable. So then you can assign this variable to the value. So the same thing, because the PTR is a variable name. So then you just need to using the asterisk to dereference this PTR to refer to the memory address and assign the value. So afterward, of course, you can display the value here. So make sure you will run the program on the IDE. So this IDE, the same thing. We will create one PTR pointer. We're using the new. So then how about we just try to using another value called double. So then we have a double data type. So we have this pointer we call dptr. So then you see just new double. So then we can have our PTR assigned to the value. So we can have our dptr equal to a double value. So then we can display both of them. Okay, so then make sure you will test on your compiler, test on your IDE. So then we can run the program to see the result. Okay, so you can see here your PTR display the 99. Then you have your DPTR 100.12. So we don't need to using the delete. So the smart pointer, they will automatically to remove the data, to remove the memory location. Right, so you can see actually you cannot really tell. Did I release the memory or not? Yeah, because that's all from the back end. We just can understand how our program does. So then we do our best. So before when we're using the new, we need to do the delete manually. So now if you have your smart pointer, so then they will automatically to delete the memory for you. So example 10 actually demonstrates the unique PTR to refer to a variable. But usually we don't really do that much. So most of the time when we're using the pointer to dynamic allocate memory, we do that for the array. So then we will see how we will do the unique PTR to create the dynamic array. So then you see the same thing. When you have your unique PTR, your angle bracket will specify your data type. So if you have an array, you just need to do the data type with the square bracket. So that's the data type. So then here, when you have your data type is int array. So when you create a new, you also do this way, the same thing. You will new your array with your size. So the notation in the angle bracket indicates the pointer will point to an int array. Of course, we don't know the size until you new. So when you new, we know how many elements of the int you want to create. So that's why they will allocate corresponding memory size for that. So afterward, your PTR is a pointer name, and also we can using that as a array name to associate with the square bracket operator. So afterward, we can assign the element with the data. We can display the data. So then the next example, in example 11, we will see how we're using the unique pointer to create an array. So the same thing, you need to include your memory library. So then we will ask the user how many number you want to enter. Right, so you will see here, because you're using the new keyword. So earlier we say this one we're using the constant number. So we create the array size is constant. But this one, because they are using the new keyword. So that's the dynamic memory. Dynamic memory, when you create the array, we allow the either constant variable or a non-constant variable in the square bracket to specify the size. So that's why here you can see we have this one to do that. Okay, so how many number do you want to enter? Okay, so then you see you have your maximum number. So then you have your unique PTR int array. So then we will have the number we just get from the user input. So we knew this int array. So then we will get the value for the array. So one thing is, you see this PTR is a pointer name, and we can using that as array name to associate with the index. So in the for loop, we will ask user to enter the value. So then we can assign to the each element one by one. Then we will display the result. So make sure you download example 11 and run from the IDE. So right, like we say, since you're using the dynamic memory, when we create the array, you can ask the user, you save the value into a variable. So this one, we're using the unique pointer to create the array. So then the pointer name is PTR. Then we're using the new keyword to create the array. So then afterward, PTR actually is referred to the beginning of the array. So we can ask the user to give us a number one by one. So then another for loop will display the value. So then you see you can run the program. Maybe we just give the user only 4 value. Okay, so then enter an integer value. Okay, so then they will display the result. So then you can see here in your smart pointer, you're using the new keyword, but you don't need to worry about using the delete to release the dynamic memory. So that's the smart pointer example.